of bisector angle. Equation of the angle bisector of the pair of straight lines ax square plus 2hxy plus by square equal to 0. Statement: the equation of the angle bisector between the lines ax square plus 2hxy plus by square equal to 0 is x square minus y square by a minus b, which is equal to xy by h. Because there are two lines in ax square plus 2hxy plus by square equal to 0, so the angle between bisector angle between the equation of the bisector angle of those two lines is x square minus y square by a minus b, which is equal to xy by h. We'll see the proof. We know that pair of lines ax square plus 2hxy plus by square equal to 0 is the combination of two straight line passes through the origin. So we are going to take those two lines as y is equal to m1x and y is equal to m2x, right? Two lines. That means y minus m1x is equal to 0 first line, and y minus m2x is equal to 0 the second line, right? Which is the two lines in the pair of straight lines ax square plus 2hxy plus by square equal to 0. Let us take as it is, right? Let xy be any point on the angle bisector between the lines 1 and 2. So there are two lines. So in between we are drawing a angle bisector. So that will divide the line, right? The two lines with equal angle, right? Angle bisector, so which divides the angle between these two lines with equal part, right? Suppose if it is 60 degree between these two lines 1 and 2, then this angle bisector divides 30 30, right? Exactly, it cut the angle in two equal parts, right? So xy be any point on the angle bisector. Suppose we are taking the angle bisector, right? Suppose consider any point on that angle bisector. What we'll do, just measure the distance from the point xy to the first line, right? And similarly you measure the distance from the point xy to the second line. So this is exactly middle of these two lines, right? So the distance from xy to that first line, which is equal to the distance from xy to the second line. So both distance should be equal because this is angle bisector, right? That is the concept, right? Now the distance from the point xy to the line 1, which is equal to the distance from the point xy to the line 2. That is equation number 3. Now we know distance from any point x1 y1 to the line ax plus by plus c equal to 0. The formula is modulus ax1 plus by1 plus c divided by root of a square plus b square. We are going to use this formula to find the distance from xy to first line and from point xy to the second line. So then we are going to equate them, right? So first 3 implies, so distance from the point xy to the line 1, instead of x1 y1 you put xy, right? Instead of a, check the first line, right? Y minus m1x is equal to 0. So a is the coefficient of x. In the first line, what is the coefficient? Minus m1. So instead of a you have to put minus m1. Then by, coefficient of y is b. So in the first line, coefficient of b, y is 1, right? 1 into y, right? So b is equal to 1. But there is no c, right? So instead of c you take 0. So you will get the distance minus m1x plus 1 into y plus 0 divided by root of minus m1 square plus 1 square equal to 0. Similarly for the second line, take the second line, instead of a you put minus m2, instead of b you put 1, instead of c you put c is equal to 0. x1 y1 is xy. So you will get the distance, right? Minus m2x by plus 1 into y plus 0 by root of minus m2 square plus 1 square. both are equal, right? Now we are going to remove the modulus. When you are removing the modulus, you have to put plus or minus, right? Similarly, like square root, right? If it is 25, which is equal to 5 square, that means when you are taking square root, you take plus or minus, right? Same idea, same concept we have to use, right? So that is that is y minus m1, right? Y minus m1x divided by root of 1 plus m1 square, which is equal to plus or minus. So we are putting plus or minus on one side, right? Plus or minus a square, which is equal to 25. Then a is equal to plus or minus root 25. We are putting, right? Same concept we have to use for modulus also. Y minus m1x by root of 1 plus m1 square, which is equal to plus or minus y minus m2x divided by root of 1 plus m2 square. Squaring both sides, you will get y minus m1x by root of 1 plus m1 square the whole square, which is equal to plus or minus y minus m2x by root of 1 plus m2 square the whole square. So separating the square, right, for the numerator y minus m1x the whole square, left hand side, right, divided by square root of 1 plus m1 square. Square and square root get cancelled, you will get in denominator 1 plus m1 square on the left side. Now come to the right side, same idea. So y minus m2x the whole square numerator divided by square root will cancel in the denominator 1 plus m2 square. Then you cross multiply the numbers. So 1 plus m2 square into y minus m1x the whole square, left hand side, and 1 plus m1 square into right hand side, y minus m2x the whole square, right? Then you just multiply with that number, 1 plus m2 square, right? So we are now we are going to use a minus b the whole square formula on the left hand side. So a square y square plus b square m1 square x square minus 2ab 2m1xy into 1 plus m2 square. Similarly on the right hand side, using the same formula, y square plus m2 square x square minus 2m2xy into 1 plus m1 square. Next you just multiply 1 plus in the left hand side, 1 plus m2 square into each term. So first term 1 plus m2 square into y square, then second term 1 plus m2 square into m1 square x square, third term 2 minus 2 m1 into 1 plus m2 square into xy on the left hand side. Similarly on the right hand side, 1 plus m1 square into y square plus 1 plus m1 square into m2 square x square minus 2 m2 1 plus m1 square into xy. Now we are bringing all the right hand terms to the left hand side, right? So we are changing the sign of those terms, right? That is 1 plus m2 square y square plus 1 plus m2 square m1 square x square minus 2 m1 1 plus m2 square xy. Then we are bringing those terms from the right hand side. First term minus 1 plus m1 square y square minus 1 plus m1 square m2 square x square, that minus become plus 2 m2 1 plus m1 square xy equal to 0. Now we are going to group y square term, x square term, then xy term. First y square term, first term 1 plus m2 square y square, right? Then the fourth term minus 1 plus m1 square y square. So y square is common, take it outside. So 1 plus m2 square minus 1 plus m1 square into y square, first term. Then x square term, second term is x square, right? 1 plus m2 square m1 square into x square, right? In the previous step I am talking about, right? 1 plus m2 square into m1 square x square is there. Then fifth term minus 1 plus m1 square m2 square into x square. So grouping these two, so we will get 1 plus m2 square m1 square minus 1 plus m1 square m2 square into x square. Then we are going to the previous step. So xy is common in two terms. So first term is 2 and 2 also common in those terms, right? m2 into 1 plus m1 square, right, minus m1 into 1 plus m2 square into xy equal to 0, right? So multiplying, removing the brackets, so 1 plus m2 square minus 1 minus m1 square. Similarly, m1 square plus m1 square m2 square, then minus m1 square m2 square and minus m2 square. So removing all the brackets, right? So m2 m1 square, then m1 m2 square, then m2 minus m1 into xy, that is equal to 0. So m2 square minus m1 square into y square, then m1 square minus m2 square into x square, plus 2 m2 minus m1 plus m1 m2 taking common, right, outside from the m2 m1 square, then m1 m2 square, m1 m2 common, take it outside, m1 m2 into m1 minus m2 into xy equal to 0. So we are using a square minus b square formula, a plus b into a minus b, m2 minus m1 into m2 plus m1 into y square, plus similarly m1 minus m2 into m1 plus m2 x square, plus 2 into we are taking minus outside from the first two terms, minus m1 minus m2 plus m1 m2 into m1 minus m2 xy equal to 0. Next, minus, we are taking minus outside from the first term, minus m1 minus m2, so reverse the term, right, plus into m2 plus m1 y square plus m1 minus m2 into m1 plus m2 x square, plus 2 in that both term m1 minus m2 is common, right, take it outside, 2 into m1 minus m2, right, so m1 m2 minus 1 into xy equal to 0. So that means minus m2 plus m1, right, m1 minus m2 common in all term, so we can cancel those terms because which is equal to 0 the equation, right, so we can remove m1 minus m2 from the all terms. So remaining minus m2 plus m1 y square plus m1 m2 m1 plus m2 x square plus 2 into m1 m2 minus 1 into xy equal to 0. So minus m2 plus m1 y square plus m1 plus m2 the x square, which is equal to, taking that xy term to the other side, minus 2 into m1 m2 minus 1 into xy. So here m1 plus m2 is common, take it outside, so x square minus y square, which is equal to 2 into 1 minus m1 m2. So we are multiplying with minus, so plus 1 minus m1 m2 into xy. That is equation number 4. So given ax square plus 2hxy plus by square equal to 0, that is the given pair of straight line, that is equation number 5. The pair of straight line equation passing through the origin, which is the combination of two lines, already we mentioned in the first line of this problem, right? Now we are going to take this equation and divide it by b, right? So divided by b, a by b x square, 2h by b xy plus b by b 1, that is y, plus y square equal to 0, that is equation number 6. We know that pair of straight line with slope m1 m2 and passing through the origin is given by, because this is a combination of 1 and 2 line, so we are multiplying 1 and 2, we will get this line, right, we already saw in the previous videos, right, that is y square minus m1 plus m2 xy plus m1 m2 x square equal to 0. So these represent the same line, right, that is the pair of straight line ax square plus 2hxy plus by square equal to 0, and also the same line becomes a by b x square plus 2h by b xy plus y square equal to 0. This line represent 5 and 6 same, right, all three are same, seventh equation. So from 6 and 7 we are comparing the coefficient. So seventh equation is nothing but fifth equation and sixth equation, all three are representing the same equation, right? So we are comparing, we are taking 6 and 7 and comparing the coefficients. A by b, So x square coefficient of x square, so a by b. In the seventh equation, x square coefficient m1 m2, right? A by b is equal to m1 m2. And xy coefficient in 6 is 2h by b. In 7 is minus m1 plus m2, right? So m1 m2 is equal to a by b, m1 plus m2 is equal to minus 2h by b. So we are going to, this is 8, we are going to use 8 in fourth equation, right? So substituting so fourth implies m1 plus m2 is equal to x square minus y square, which is equal to 2 into 1 minus m1 m2 xy. Substituting the values of m1 plus m2 and m1 m2 from equation number 8. So minus 2h by b x square minus y square, which is equal to 2 into 1 minus a by b x. So minus 2h by b x square minus y square, which is equal to 2, taking the LCM, b minus a by b xy. So both sides we are having b in the denominator, you can cancel both, right? So you will get, and 2 also common in the numerator, equal, right? So you can cancel 2 by b on both sides. So remaining minus h into x square minus y square, which is equal to b minus a into xy. So h into multiplying with the minus on the other side. So whole equation multiply by minus. So minus into minus plus h x square minus y square on the left hand side. So when you are multiplying with minus, minus b minus into minus plus a. So it will become a minus b xy, right? So x square by minus y square, bring that a minus b on the right hand side to left hand side, it will come to the denominator, x square minus y square by a minus b. Take the h to the right hand side, which is in the left hand side, right? H is in the left hand side, you take that h to the right hand side, so it will go to the denominator, so xy by h, which is the required equation. Thanks.